Okay, hello, it's Miss Elliott. Today we are going to take notes on the side, congruence postulate. Remember that a postulate is just a statement that is assumed to be true. So, the question that we want to be able to answer by the end of this video is, what shortcut can I use to prove triangles are congruent? So what I mean by shortcut is this. Yesterday, when we talked about congruent figures, we had to match up all the angles and all the sides. So specifically in a triangle, you need 3 pairs of congruent sides, 3 pairs of congruent angles. And so when we have a shortcut, that means we don't need all the sides, all the angles. You can make a conclusion based on the given information in certain situations. Now, the congruence shortcuts that we have, there's 5, but today we're only going to talk about 2 of them. The first one that we're going to talk about is this side congruence postulate. It says if 3 sides of a triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. And I want you to recall that for figures to be congruent, that means all their sides and all their angles are congruent. And so here, just by looking at the sides, we can make a conclusion, a grand conclusion, about the triangles. So another way to look at this, let's look at our figures. Using these examples, what our postulate is saying is that if side AB, which is here marked with 1 tick mark, is congruent to, well, this one's marked with 1, RS. If side AB is congruent to RS and side BC is congruent to ST and side CA is congruent to TR. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So now I can say that triangle ABC is congruent to triangle, well, we gotta remember here when we're writing this congruent statement that order matters. So triangle ABC is going to be congruent to triangle RST. Let's look at some examples where we can prove that the 2 triangles are congruent by just looking at their sides. It asks us here, is triangle DFG congruent to triangle HJK? So let's look at our figure. Here we have a side DG that's marked with 1 tick mark and it's congruent to HK. DG is congruent to HK. Well, how do we know that? It was given to us in the picture. They're marked. Anything that's already marked in a picture, that is something that you are given. Well, let's look and see what else we're given. Right here, DF is marked congruent to HJ. That is also some information that we were given. And we have this third side, FG, marked with 3 tick marks. That means it's congruent to something, and it's congruent to JK. FG is congruent to JK. How do I know that? It was given to us in the picture. That's what those tick marks mean. So, are these triangles congruent? Well, this is a pair of sides. Here we have another pair of sides. And here we have another pair of sides that are congruent. So the postulate above, the side, side, side congruence postulate, would say, yes, those triangles are congruent. Why? Because of side, side, side postulate. So I want you to notice that I wrote here are statements listed out. I listed out here what's congruent. And then here I wrote why we know it, because it was given. This is to prep you for proofs. We will do a proof at the end of notes today. So this next question asks us, is triangle QPT congruent to triangle RST? Well, let's find out. Let's see what information we're given. We are given that QT is congruent to RT. Based on the 1 tick mark. Now these sides are marked with 2 tick marks. That means that QP is congruent to RS. So based on the given information, we're going to see what type of conclusion we can make. We're also given that PT is congruent to ST. PT is congruent to ST. Given information. So, is triangle QPT congruent to triangle RST? We have side, we have a side, and we have a side. So, yes, these triangles are congruent. Why? Because of the postulate above. Because of side, side, side postulate. Flip your paper over to the back, and let's look at counterexamples. Let's look at when side, side, side doesn't work. Here we are asked, is triangle ACE congruent to triangle BDF? So I'm reading my statement, ACE, is it congruent to triangle BDF? Well, let's see. Based on how my statement is written, AC would have to be congruent to, AC are my first 2 letters, would have to be congruent to the first 2 letters in the other triangle. The first 2 vertices would have to be congruent to BD. Let's look at our picture and see if that's occurring. AC is marked here with 1 tick mark. BD has 2. They're not congruent. Now, CE, marked with 3, is congruent to DF. CE is congruent to DF. And then if we look at the last piece, AE, the first and the last, would need to be congruent to BF, the first and the last in the second statement. So let's look and see. AE has 2, but BF does not. They're not congruent. Now, I think it's clear to see that these triangles are congruent, but this statement is incorrect. So, is triangle ACE congruent to triangle BFE? No, they're not congruent. These, you would have to rearrange your congruent statement for this to be true. Now let's look at this next counterexample. Before we move on, I actually want you to write right here, order matters. Let's look at this next example, but it's a counterexample. Remember, this is going to be a time where side, side, side does not work. Based on the measurements, here we have this side is 7, BC, and this side is 7, AD. BC is congruent to AD. BC, AD. Then, these triangles share a side. AC is congruent to itself. Now to use side, 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 all three pairs have to be congruent. If we look at AB, AB is 3 units long. And the last remaining side is CD. Well, CD is 4 units long. These sides are not congruent. So when it asks, are the triangles congruent? No, they're not the same size, they're not the same shape. Because these sides are not congruent. Because 3 does not equal 4. What is the conclusion I want you to be able to make? What is the summary to sum all of this up? Summary is this. If 3 sides of a triangle are congruent to 3 sides of another triangle, then the 2 sides are congruent by the side, side, side congruence postulate. That is again, if 3 sides of a triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent by the side, side, side congruence postulate. This is called side, side, side. And remember, when you're writing your congruence statement, remember that order matters. All right, get ready to take notes.